Welcome back, everyone. Now for this panel discussion on accelerating power sector transformations with AWS, please welcome our moderator, Sainath Bandakavi, our Senior Solution Architect at AWS.
Good afternoon. Welcome to the session on accelerating power sector transformation with AWS. My name is Sainath. I'm a Senior Solutions Architect with Amazon Internet Services Private Limited. And I work with customers and partners in the power and utilities domain to help them build solutions on AWS Cloud. So along with me, I have Mr. Manoj, who's the head of IT for TP Western Odisha Distribution Limited. And I also have Mr. Jigar Jain, who is the product manager with Power Trading Corporation. So this is what we'll be covering today. I'll take 2 slides on overview of electricity supply chain, and then I'll talk about cloud computing benefits, mainly in the utilities context, and then I'll hand it over to Manoj and then to Jigar. Okay. So all of us are consumers of electricity, right? Be it at home, be it at office, be it at this hotel, malls, theaters, everywhere. But in order for this electricity to be delivered at these places, there is an entire supply chain or a value chain which is running behind this, right? Which starts with the power generating companies who are generating the power, be it thermal, wind, coal, solar, so different types of generation, which is then sent to the transmission utilities, which in turn they send it to state transmission utilities. You would have heard names of, say, Power Grid or Madhya Pradesh Transco or Maharashtra Transco or Delhi Transco and all, right? So what they do is they are primarily bringing the electricity from the power generating companies and then giving it to the distribution companies, right? So distribution companies could be in Delhi, you have BSES, you have Tata Power. So these distribution companies, what they do is they deliver the electricity at various voltage levels to end consumers like you and us, or it could be industries, it could be malls, it could be buildings, right? And these connections are metered based on which they generate the bills and we make the payments, right? So there are a lot of financial transactions which are happening in this entire value chain. The bills that we pay goes back to the utility, but they also need to buy this from the generating companies, right? And this happens through long-term contracts, short-term contracts. It could be through power trading. That is where PTC comes into picture. And the distribution part is something TP Western Odisha does for certain parts of Odisha. So they will be covering their experience on AWS. Okay. Now across this entire value chain, there are a lot of systems which are used. It could be things like SCADA, it could be smart metering, it could be billing, various different types of systems which are used. And some of these systems are running on-premise, and many utilities are moving towards cloud, right? And they are moving towards cloud because they are seeing some advantages of why they should move to cloud. And in the next slide, I'll talk about what are some of the benefits that utilities are seeing when they are moving to cloud. Okay. So first and foremost, the increase in speed and agility that they get, right? So if you want to say implement a billing system on cloud, if you want to run it, say, on virtual machines, if you want to use managed services. So all these are available probably in a few minutes time span, and so that you can get started with running your applications. Similarly, in utilities, there is a lot of data which is gathered, be it from SCADA, be it from smart metering. A lot of data is gathered. Imagine you have a system which is already running on cloud, and you want to further build analytics on top of it. It could be things like, say, revenue analytics. It could be, say, you want to analyze the billing patterns. You want to analyze the metering data. So if you want to get started with, say, analytics, all you have to do is subscribe to, say, services like Data Lake, or it could be a querying tool like Athena, or it could be a BI dashboard. So the speed at which you can subscribe to these services and get started running is much more faster when you move to cloud, compared to, it could take weeks or months if you want to do this on-premise. So that's one of the reasons why many utilities are looking at moving to cloud. Another reason is, capacity planning, right? So if you want to, say, implement a system on-premise, what we typically do is, we guess the capacity which is needed probably, 3 years from now, 5 years from now. And all the guesswork may not really turn out to be right all the time, right? Say you assume today I have 1 million consumer base. 5 years from now, I would be having, say, 1.2 million consumer base, right? So you might be having 1.5 million, or you might be having 2 million, you never know, right? But if it is on-premise, you are probably stuck with performance issues, billing taking a lot of time or metering taking a lot of time. But when you move to cloud, you can stop guessing this capacity because there are things like, say, auto-scaling or serverless, which actually makes this compute available to you on demand. So you are not getting into problems of your systems not running or performance issues coming up, right? So another reason is in terms of the building large data centers on your own and then running your applications. So there's a good analogy about say electricity and cloud, right? Say if you want electricity at your home, we don't build generating stations of our own, right? So you go to a utility company, they give you an electricity, you consume electricity, and you pay for only what you consume. Similarly, in the case of cloud, all this heavy lifting of building the data centers is done by cloud solution providers like AWS, who build the data centers, manage the data centers. For you, it is more about subscribing to those services that you want and running your applications and paying for what you're using. Similarly, replicating those use cases is much easier. So in India, probably we have 50 plus utilities, distribution utilities at least. Globally, there would be thousands of utilities. Imagine you developed an application that you want to replicate across other utilities. When you talk about cloud, replicating these is much more easier on cloud than doing it on-premise. When we do it on-premise, it's literally like you are building everything from scratch, setting up systems, installing operating systems, and this goes a few weeks, few months, many a times. Right. Another reason is it's because pay as you go. Like the previous example I mentioned, today you have 1 million consumers. A few years later, you're probably having 1.5 million consumers. So if it's an on-premise, you're probably paying for that compute needed 1.5 million consumers 5 years later. You are paying for what you need today. Like, you're paying for the compute or the capacity which is needed today. And when you're touching 1.5 million consumers, that's when you pay for the compute or the capacity needed at that point of time. So these are some of the advantages why many utilities are considering moving to cloud. And we have TP Western Odisha and PTC also talking about their experience. So now I would like to invite Mr. Manoj Kumar. He heads IT for TP Western Odisha. And if we can talk about their experience of running revenue management system on AWS.
Good afternoon. So thank you, Sai, for introducing me. And let me give further introduction about myself and my company. So first of all, how many of you are from Delhi here? And how many, anyone of you are consumer of TPDDL? Oh, there is a one. Okay. So if you are TPDDL, then I'm from TPWODL and part of same family. Let me explain you that. So again, my name is Manoj Kumar, and I head. Can I change this slide, please? Yes. And my responsibility at TPWODL, which is a short form of TP Western Odisha Distribution Limited, is to implement IT quite literally from scratch and maintaining IT operations there. So TPWODL is a joint venture company of Government of Odisha and Tata Power. It's like TPDDL. It's a public-private partnership company. And it came in being on 1st of January 2021. This is, there are three more companies in Odisha, which is again a joint venture. There are all joint ventures between Tata Power and Government of Odisha. And three of the company came in the being on kind of a span of 6 months time. So in 3 months time, in fact, in January 1st, 2 companies were formed and another company came in the month of April. We are serving, TPWODL is serving western region of Odisha, and we have a population base of around 88 lakhs, and we are serving consumer base of around 22 lakhs as of now. And it's a vast geography. It's a 48,000 square kilometer, and urban area is very less. Industrial area, fortunately, we have good pockets of like Sambalpur, Rourkela kind of places are there, very heavily industrialized. But most of the population lives in villages and also hilly villages kind of. It's a far-flung area. So We get power from Gridco, state-owned supplier at 33 kV level, and we supply depending on the consumer type at ST, EST consumer at 33 kV, 11 kV and also at LT load like our household. Since inception, we have number of, because we all knew that when we reached there, in fact, in Odisha, there were hardly IT available. There was standalone systems, penetration of in desktop, laptops, basic IT thing, not available. But in a 1.5 year kind of duration, we have implemented many technologies there. IT interventions are too much. And what I'm presenting you here is that the customer for initiatives are these things. So for connection management, there was paper-based connection management thing that you have to fill a form, then get connection. Now we have made it completely paperless now. It's just a call away. In fact, a missed call away that you get connection there. For all domestic consumers can get connection just calling us or giving just a missed call there. So complete automation, digitization of that connection process happened. For metering also, if anybody is connected with the utilities, that meter changes happens either through the new connection or some changes or mass replacement of meter happens. And there we had an issue that we were not getting real-time data from the field. And then we implemented something called homegrown system. One application is there, which is Android-based application called Manak. So that is there. And advantage is that whatever data you get from field, immediately it syncs up with the backend system. So there is no loss of data, no manual human error is seen now. Spot billing is now everywhere. Here also we implemented there as well. So meter reading and billing function is one. And on one shot, you get both the thing. On collection, this was a very important thing. So I will explain further. But collection is very important for the entire viability of entire this sector, utility sector, power sector. And there, collecting from small consumers is a very difficult thing because most of the places you will find there is no internet connectivity. So first of all, we developed a application that is an Android-based application which runs on iOS also. And it's called Mudra. And beauty of this application is it runs in both mode. Both mode means wherever internet is available, connectivity is available, then data sync up with the backend system in real time. Where it is not available, still you are able to connect it. And when the collector comes in the region where internet is available, data gets synced up with the backend system. Plethora of many initiatives since the beginning itself we have done for customer-centric initiatives are there. In 2 months' time, when we acquired this business, we implemented a call center. Before that, there was a number and 2 telephone lines. Now it's a full-fledged contact center. And subsequently, we added from calling to all form of servicing is available, email-based, WhatsApp-based, and even if somebody is complaining or giving suggestion through social media like Twitter, we are able to service that. If you see a business of power distribution company, there are only 2 functions or major functions are there. One is giving reliable uninterrupted supply, and then the commercial function, that how you give connection, you get money from, you bill it, invoice it, and then get money. And if somebody is not paying, disconnect or then thereafter reconnect. So this is the 2 distinct functions are there. And there are functions because for all these things you need to internal processes you need. Accordingly, systems have been prepared, so implemented. So one side you see that we call OT, operational technology, SCADA, GIS kind of thing we implemented, and the field force automation kind of thing which has happened. Then for all internal processes, all companies implement ERP. We have also implemented ERP for procurement, asset management, finance, HR, even IT to some extent. So then ERP has been implemented. But where we want to focus and where Sai also focused on that, this is the big chunk. This is very important. Then the first slide, what Sai showed you, the electricity flows from generating station to your household or to industry, but money comes backward. And if the last consumer is not paying, entire system, no generating company, no distribution, no transmission company, nobody will can survive. So collecting money from that, so the commercial function in any utility is very, very important, not only for the utility itself, but for the entire ecosystem of power business. So there, this is a complete revenue support system, revenue management services, where collection, billing, metering, disconnection, all things we have asked, we have told, and also complete thing on customer-centric initiatives. These all are part of revenue management system. From there, there are linkages also. Like you are doing collection, then the collection should go into finance system. And likewise, if you have some outage, then the information should go to call center. So that kind of integration is required. So we are collecting and we have made architecture. All kind of data is coming in one repository. And on top of that, for managing everything, we have a system, management information system or dashboard, reports, everything. Where we want to focus today is this part. Effective revenue management, as I mentioned, is very, very important for the viability of the sector and the company itself. So now let me tell you, so I told you that when we joined there was hardly any implementation of IT there. What we got as a legacy system, a non-integrated billing engine, which has no connection with the user. So you offline run some billing, distributed the bill, and so there was no integration at all. So there was a desperate need to have a revenue management system up and running very quickly to safeguard, to stop leakage of our collection, and that was very, very important for success of our company or any company for that matter. Second thing was we were given, because when we went there, government has already pumped money through IPDS scheme. Those who are part of this, they will know RAP, DRP and IPDS scheme. Government funds a lot of, gives money for distribution companies. So that money was given. But the problem was we wanted to be up with so data center was delayed, by the way. And there was a dependency on it. And it was in our interest and everybody's interest that we keep this revenue management services up and running as soon as possible. And the legacy system was in such a state that no customer-centric or commercial function thing can be further built on that. And there, time was the essence. So the partner who was implementing this system, even before we joined there, they came up with the idea that you want to run this system. They came up with the idea that we can build this system, complete revenue management system on AWS. And as I told you, 3 companies at the same time got incorporated there. And we were all running in the same boat, sailing in the same boat. And they came with the idea that we should be running this system on AWS. We kind of validated that idea. We found this is really good. And that's how we said, okay, for AWS, that we should be running on this thing. That helped us, any dependency on data center coming, on-premise thing coming, before that, we could be up and running on the AWS cloud. So this is how genesis of this revenue management services running on AWS cloud. And what we did, in fact, so we thought about in the Q1 ending, so I'm talking about the last year's quarter, 2021 financial year. And Q2, we finalized and also tested that whether it will work or not. And we found it is working very well. We optimized the solution there also. And in phases, by Q4, everything was up and running from the AWS cloud. And those who would be knowing about it, there are 2 silos of customers in utility. One is industrial consumers, who are less in number, but bigger consumer of electricity. And then there are LT consumers, large in number, where customer service is very important, but they are small payments. Bill size invoice size will be very less. So what we did, we migrated the load on AWS with the HTAST low in number consumer-wise, but high in revenue, and then slowly migrated to single phase, and single phase happened on 2 phases. And by the way, while doing this transition, we also monitored how my infrastructure is behaving. And we accordingly adjusted also. And this is the beauty of cloud, that you can adjust, you can add compute, storage, whatever you need as you go. And that's how we did that. Little technical, but I think it's easy to understand. Here is the part that your users are connected to internet. Here is AWS cloud. And what the cloud is generally understood as safe, but still we have not taken chance. Very critical systems are running on cloud also. So what we have done, we have implemented in 2 availability zones are there. It's a kind of a DR, you can say, or a near DR kind of situation. And I just heard that another center is coming in of Hyderabad. So maybe that availability zone may be from different data center of AWS will be running. But as of now, 2 availability zones are there. We have implemented AZ1 and AZ2. This is the primary one. And so here, all authentication, billing engine, all data, so CRM, everything is here. And then below that, you can see the primary database on the other zone. There is a replica of the database is there, and there is a native replication between that two. And then we have a backup. And then for archival data, we have used S3 Glacier. And then for monitoring the performance of everything, this is on CloudWatch. So dashboard and how my systems are performing, that is there. And to switch between the two things, the intelligent aspect is here, elastic load balancing thing is there. And this is entire on AWS. So just to sum up whatever I told you, that we are running our infrastructure, that this RMS on AWS. As of now, we are serving more than 70 lakh consumers on this. And TPWODL alone has around 22 lakh consumer running on that. And you can understand from what kind of transactions happen. In any per day transaction will be around 2 lakh kind of transaction is. Sorry. We have used Amazon EC2 instances for web layer, application layer, as well as for database layer. As we spoke, we have used multi-zone, basically 2-zone architecture is there. We have used Amazon S3 for store backups and CloudWatch for alarms and dashboards. So this sums up whatever I have spoken so far. So Sai already explained, but I can tell you from my experience that how cloud help. When we have too many unknowns are there. So one more thing I can tell you, that our data center was designed only for 40 lakhs consumer. And whereas when we came, we have to run 70 or more than 70 lakh consumer on that. And you don't know that how much, because whatever capacity you will plan, it may be over capacity or it can be under capacity also. In that kind of situation, it is better to go for cloud. So that kind of flexibility of adding compute, storage, everything, that kind of advantage we got. And this is also at times came, like for beginning of the month, when you have a lot of billing to be done, that time you need to compute on demand. So that kind of thing we got there. And one more thing is there. When we don't know everything, that time blocking your capital on certain technology is not a wise thing. So cloud gives us flexibility that you don't block your capital, which is much needed for any business, and pay as much as you can, as you use. And finally, if I have sum up, then only one phrase I can say, that cloud has given complete peace of mind. This is all I wanted to present, and over to you, Sai.
Thank you so much, Manoj. Now I'll request Jigar from PTC India to come and talk about how they are using AWS serverless to leverage for their bid automation system.
Thank you, Sai. Good afternoon, ladies and gentlemen. My name is Jigar Jain. I will be talking about bid automation system on AWS serverless. But before I get into it, I'll give you a brief about PTC India. So PTC India was formerly known as Power Trade Corporation of India Limited. It was founded in 1999 as a Government of India initiated public-private partnership. The focus of this organization is to create a commercially vibrant power market in the country. As of today, PTC India is the largest power trading company in India. Just last year, we have sold over 80 billion units. And most of these 80 billion units comes from either long-term, short-term, medium-term power purchase agreement or through trade through open access. To manage all this trade, PTC had developed a system what we call as BIAS, or the bid automation system. So the bid automation system is also known as Bijli Vyapar to most of our clients. It was developed in 2010 to cater the needs of the market at that time. Over the time, BIAS has seen a lot of updates. And as of today, apart from other things, BIAS also manages day-ahead market, real-time market, and also green market transactions. Since BIAS is so business critical, high availability of BIAS is our utmost importance. As of primary users, we have power distribution companies and power generation utilities. As per the load, we have on an average 150 to 200 clients logging into our system between 10 a.m. to 12 p.m. for the day-ahead market. And as per the real-time market, the load can be anything all throughout the day. So this is what BIAS looks like. Please note that this is not the actual representation of BIAS. It is just a high-level overview of what it is right now. So it is essentially two giant EC2 instances, one hosting the application and another hosting the database. As for the application, it is a Java-based application written in struts2, and as for the database of choice is PostgreSQL. So not much jazz over here. So if a client wants to use the service of BIAS, he can log in through the web app from the browser or through the mobile app available both in Android and iOS. Once the request is sent out, it is first received at the firewall. If everything goes fine, the request is sent back to the proxy server and back to the application. Within the application, the request is received at the controller, and the controller then in turn calls the classes and functions required to address that request. And then once you have the output, it's sent back. Everything good and fine, right? But with this architecture, we see a lot of challenges almost on a daily basis. The first one and the most important one is that we see a lot of downtime. Let me explain. So anytime we need to roll out a new update, we need to stop the service, upload the new files, and restart the service again, hence the downtime. And as I said, high availability is our utmost importance, so downtime is not something we can live with. Secondly, over the time when BIAS was updated, there were too many modules defined interdependent to each other. Since there was so much high cohesion, today if any module crashes, the whole system comes down. So we have to again stop the service, go back to the old one, and restart the services, which is really bad. As for scaling, we obviously can scale, but only vertically. What I mean by that is that you can always just add number of cores or number of RAM you want, but it's inefficient. I don't need those RAM and CPU all the time. So to address this challenge, we went back to the drawing board and we were thinking what can be done, what new architectures we can come up with. So we went ahead, our first choice or our first proposed solution was to go the microservice-based container route. What we would do is we would break the whole chunk of code into small microservices, attach database to it, containerize the whole thing, and run the whole thing as a Kubernetes cluster. And it would have worked amazing. What it would do, it would give me no downtime for updates. Since everything is a small service, if I want to update one service, I can do that just by changing the version of that service, giving it to the cluster, and let Kubernetes do its thing. Again, for the crashing modules, if the module crashes, again, the system does not crash. We are still in the safe space. And if it does, we can always go back to the previous version just in a matter of clicks. As for scaling, it is a breeze. You can scale up as many containers as you want when you want them. So once you have the load, you can scale up your containers. When the load has disappeared, you can go back to your initial configuration. But this too comes with the challenge, right? So we will have to rewrite a lot of code. But if somebody noticed in the later screens, we were using struts2, which is already at end of support. So we would have to do it anyways. So not a problem. But the major problem was that we would have to train all our developers to develop a containerized friendly services, which would have taken time. Also, we would have to have a complete DevOps team hired to manage the cluster and the versions of the cluster. And service discovery and hosting in multiple regions would have been very tedious. So we went back to the drawing room, scratching our heads, thinking, what can be done? So at the same time, Sai and team at AWS came to us and they were like, hey Jigar, why not go serverless or cloud native? So I hopped onto Google to search what cloud native was, and due to lack of definition there, I came up with one of my own. So what is going cloud native? It's basically using the distributed nature of the cloud to exploit it to achieve real-time scaling and high availability through continuous ingestion and continuous delivery. What it gives me is no infrastructure to manage whatsoever. Automatic scaling, I do not have to do anything. I pay as I go, as Manoj and Sai just said in the before slides, and high availability and high security right out of the box. So me and Sai, we sat for a couple of weeks and we came up with this architecture. Please note that as we speak, developers at PTC are working on this exact architecture to make a POC or a proof of concept to prove sustainability of bias on AWS serverless. So what do we have here? So we have our front end written in React and has been hosted on S3 bucket. And yes, you heard me right. You can host your React applications on S3. I didn't know that. As for our backend, backend endpoints, we are using Amazon API gateways as the REST endpoints. And once any of these REST points is triggered, it in turn triggers the Lambda function or multiple Lambda function as per requirement. As of choice of database, we are using Amazon's DynamoDB because of its high scaling and high availability. And apart from that, to manage the cloud, we use CloudWatch for managing users, Cognito, and to send out notification SNS. In conclusion, or in my final notes, so hosting on Amazon S3 is almost free, right? As for Lambda functions are language independent and interoperable. I cannot emphasize on this point more because you can have 3 Lambda functions, one written in Java, one in JavaScript, and the third one say in C++, and all of these 3 can talk to each other flawlessly. What it gives you is major flexibility when it comes to hiring resources, right? Also, not all your Lambda function scales up all the time. I don't need adding users endpoint that Lambda is using to scale up all the time. So AWS serverless gives me the ability to scale only those Lambdas which I want, right? And as per adding and removing the endpoints, it's just a matter of clicks. You can go to log into the dashboard, go to Amazon API gateways, and just add and remove those in just few clicks. Finally, managing this whole infrastructure and having alert setup is super easy using CloudWatch and SNS. So that's all I had for you guys today. Over to you, Sai. Thank you.
And we encourage you to get engaged with our training and certification content. And once you start building your skills, you can. There are certifications which are at foundational, professional levels. So you can scan any of the QR codes and you can get more detailed information. Thank you, everyone.